thank you so much for having us. And let me say a big thanks to the Maharashtra Fire Services for hosting us, and also to FSAI for this great reception today. So as Manju mentioned, I lead UL Standards and Engagement. So we are a non-profit organization that develops safety standards and campaigns for safety all around the world. In fact, this year is 120 years since our very first standard. Our very first standard was for tin-clad fire doors in 1903, and it is still a valid standard. It's been updated a few times, but still a valid standard for UL Standards Engagement. So we have a really strong interest in fire prevention and the use of standards to prevent bad safety results. Underwriters Laboratories started in 1893 when electricity was first coming to buildings and those buildings were catching fire. And we needed to understand how to reduce the risk of fire in buildings. So here we are now 130 years later, and it's about electricity again causing fires, but no longer so much in buildings. Now it's in two-wheelers, three-wheelers, four-wheelers, as well as battery energy storage systems, many other different deployments of batteries. And so we are now organized in 3 different separate organizations. UL Research Institutes, which is conducting research on emerging safety issues. UL Solutions, which is a business that does testing and inspection and certification. And UL Standards and Engagement, for which Manju and I work, which is a non-profit looking at standards development. We're spending a lot of time now developing standards for all manner of battery devices to try to make sure that they remain safe. But the real focus of today is when the standards are not successful, when products do not comply, products are damaged mechanically or electrically, and then the batteries go into thermal runaway. And I think many countries around the world are now trying to deal with this. We hear from fire services in many different countries trying to learn about how to deal with lithium-ion thermal runaway leading to fires. And we've all seen the YouTube videos of so many shocking cases. Even just e-scooters can suddenly appear to catch fire and cause really horrific results. So we really appreciate you hosting us for this session. I hope it's going to be very educational, instructive. And as Manju mentioned, we want this to be just the first interaction of how we can help you with more information, because as a global nonprofit, our whole commitment is just to promoting safety. And we're very lucky to have, as a partner in this, Dr. Judy Jeevarajan, who is from UL Research Institutes and leads the Electrochemical Safety Research Institute, with a very distinguished career looking at battery safety. And watching yesterday the amazing landing on the moon, for which congratulations to India, incredible accomplishment. But Judy had a long career in NASA. And so when we think about battery safety in space, I think yesterday was a great example of an Indian EV. That was an electric vehicle landing on the moon. And how do we think about all aspects of battery safety? So again, thank you for hosting us. We are here to be your partner going forward, and just appreciate all the great collaborations.
So, lithium-ion batteries is a real challenge. Every month we come across different incidents across the nation, in Pai, in Hyderabad, in Bangalore, in Delhi, or various parts of the country. These incidences are happening. And unfortunately, we have lost life also due to indirect effects of the smokes, in spreading in the hotel or residential building above the shops or within the charging stations provided below the garage. So these are the real challenge coming up in our day-to-day life. And as a regulator, as a responder to the fire, what is the best extinguishing media we should use and how to control this fire? It is a real challenge. The interaction started with IIT Gandhinagar when UL has contributed a lot of time and efforts, when the battery manufacturers, the integrators, the fire service people all sit together and explain what are the difficulties we are facing in, day out while dealing with lithium-ion batteries. And that time, Dr. Judy helped us a lot to understand what are the nitty-gritties of this cell and how best we can overcome this problem. So I am sure today she will definitely give more inputs about the research, what they have done at UL level. So it will be beneficial for firefighters like us to deal with various types of fires, maybe data centers, maybe 4-vehicle batteries, 2-wheeler batteries, or even in mobiles also lithium batteries are used. So all these scenarios, we should be in a position to know exact what are the hazards, and they have arranged the demonstration also, the live demonstration, wherein we can really see how the furious is the explosion or the fire is of lithium-ion batteries. Thank you very much for giving us this opportunity for learning, and we are definitely looking forward as to UL as a partner in future.
So as Manju mentioned and Dr. Steele mentioned, I lead the Electrochemical Safety Research Institute, and our mission is to advance safer energy storage through science. I'm not going to go through all my slides. I just want to talk a little bit about what can happen when we have a fire and how you can deal with it. So as you all know, we have gone from really small batteries all the way to electric vehicle batteries and also stationary grid energy storage systems. So the hazards with lithium ions, although it is one of the best chemistries you can have today of rechargeable types, but because of that high energy and also because of all the chemicals that are inside, it actually can also be a very big fire hazard. Although it has what we call a fire hazard, and the reaction that is associated with lithium ion is only called deflagration. But I'll talk later in a few minutes about how it can become an explosion. The gases that come out of it can actually collect in a confined volume and make it an explosion. So I'll say a few things about that. I'm not going to go into details about the design of the battery itself. As you know, you yourselves have seen a lot of fires with not only with consumer equipment but also with EVs, two-wheelers, three-wheelers, and so on. Some of the challenges with electric vehicles especially is location of the battery. As you can see here, when you look at a vehicle, it's very difficult to tell immediately whether it's a pure EV or a hybrid EV or a plug-in hybrid EV, and also whether it is an ICE vehicle. So you can see, the battery is on the underside of the vehicle, and so getting to the battery to put out the fire is also a very big challenge for the fire service. These are some of the things that people around the world have done. They've taken the whole vehicle and put it inside like a big, they call it a water tank, so they can put out the fire. Sometimes they have a water spray that is coming from the side to put out the fire. Sometimes they use this big blanket to cover the entire EV. It actually prevents outside air from going in to make it continue the fire. So only what the cells can provide, the oxygen that the cells can provide is used in the fire, and as soon as that is done, the fire is put out. They can use a water bag like the one I showed in the bottom. And they also have different ways of transporting these electric vehicles that have gone through a fire and that are still dangerous, because you don't know whether there's any energy that is still in the battery that could become a hazard. one of the issues with moving a battery that has undergone a fire is to know whether there are any what we call stranded energy, which means some of the cells have not burned. So when you move it, you will have movement of the cells and the interconnecting tabs that can then again cause a short circuit, and you can have another fire also. So that is another concern. So they have some ways of moving the vehicle by remote access. So this is what I mentioned. You can have a reignition of the battery pack, especially if there are certain areas of the battery that are still alive. The cells are still alive. I wanted to show here that we have worked with several different types of fire suppressants. There are some that are pretty good, like nitrogen, cold nitrogen, and then some of the aerosols. But the problem that we see is that the volume or the amount of nitrogen gas or the volume of the aerosol that we're using is very limited. So if it is not able to be there through the entire time, then it is going to be a problem, because you can maybe suppress it for a little while, but then it will reignite. So unless you have it for the entire length of time to completely cool all the cells in the battery and bring it down to room temperature, you are going to see a reignition. And that's what you're seeing with the nitrogen and the aerosol suppressant. There wasn't enough to last the entire time. But with water, you can have a lot of water, and so it's easier to put out the fire with water. Again, one of the challenges I want to show is in this particular one, the module is covered, so you can't get access to the cells. So what we did, and when we did that, you can see the entire module, was destroyed by thermal runaway propagation. But when we made the hole, we were able to get the water inside, and we were able to suppress the fire. This just to show you with the aerosol, we saw reignition. So another thing I wanted people who are in the fire service and first responders to understand is the gases. There are a lot of combustible and toxic gases that come out of these cells. So one of the things you need to remember, especially if you're going into an area that is confined, you need to remember that you are going to face combustible and toxic gases. So the combustible gases, if they are above that threshold limit value, can actually cause an explosion. So sometimes, like we saw in the Arizona fire, when the firefighters opened the container, air rushed in and they had an explosion because there was so much explosive gases, combustible gases inside. So those are things that you need to keep in mind when you go to deal with a fire, which is in a confined space. Another thing that we also find is that hydrogen fluoride gas or hydrofluoric acid is also released, because hydrogen fluoride gas comes out of the cell. It combines with water and it can become hydrofluoric acid. And what we have heard from firefighters is even after 3 washes of their suit, they still find hydrofluoric HF on their suits. And HF is very toxic. The TLV for HF is 0.5 ppm. So you have to be really careful about thinking about the nature of all these gases that you have to deal with also, which can be toxic. And then another thing that I also want to point out is when we use water as a fire suppressant, because as I mentioned, HF is produced, that water and HF in the water is going to run into the ground. So you've got to be careful about, you have to think about where you are letting that water go. Because if HF goes into the soil or the ground, that is going to cause an environmental pollution. So that is also that needs to be taken into account. What we are also finding out is that the particulate emissions that are coming from the fire can also be a health hazard, because the carbon particles are so tiny that you can breathe it, and also the other metals that are in the transition metal oxides like cobalt, nickel and manganese are also very small, and you can breathe it in, so you have to be careful about those contaminants also. Just saying, these are the things that we need to be worried about. Make sure there's ventilation. We have toxic gas sensors as well as oxygen sensors, because you don't want to get inside a certain area where there is less oxygen and be affected by it. And then make sure you wear the right PPE, have the right fire extinguishers and so on. So that's the main things I wanted to share here. And I'm open to questions. I think we may have a few more minutes left. Main things I wanted to share is that whenever you deal with the fire, remember that there could be a reignition. Remember that there are combustible and toxic gases that are evolved from it, HF especially. And also think before you let the suppressant run into the ground or somewhere where it can cause an environmental pollution.
We are just capturing one data here which is showing around
बैटरी के पास
blue wala in the thermocouple is showing the, and it is continuously showing it is shooting up. That means to say probably the cell has already run into thermal runaway, but it has to propagate further.
यही ब्लास्ट होगा ना?
हाँ
ठीक है इतना?
हाँ
At the heater it is around 85.7 degrees centigrade now. Something here? Yeah, so I think it has gone into thermal runaway. See how it is going to continuously. I'm not a specialist, I'll just stand away. Yeah. So it is, now it is at 1 and now it is going to keep propagating into the other cells also. The third one. The third one. Sir, please stand away, and that is the reason we have put this cage so that the safety is taken care and. Yeah. We'll ask them to put it out, right? You can put out the विनायक जी पानी डाल सकते हैं. एक मिनट. नहीं सर बंद नहीं होगा वो फिर से. हाँ Power is on. Yeah, we can just wait. क्योंकि अभी आपको लगा कि आवाज जब चला गया ना, just wait. Yes, sir. Sure. Maybe one side if we can clear, they may be able to do what. Let's either this way or the other way. Either this way. Can you just get the water so that it can go from here? So you can see still the smoke is coming, which means yeah. Do you think it is completely put out? It will reignite, right? Still the heat is there. Yeah. Yes, the sides. You can still see the smoke. It is going to reignite. See, this is why we said it is important for us to know that you think the battery has been already put out, the fire has been put out, but it is not. It gets reignited because of the standard energy. Let's put there.
Cut it. Camera. बैटरी पे फोकस कर, बैटरी पे जूम कर, बैटरी पे।
इस तरफ से पानी डाल दीजिए ना, इस तरफ से डाल दीजिए, आएगा इस तरफ नहीं वो आएगी नहीं अभी ये आप ये कर देंगे, पानी डाल दीजिए, पानी
So this is what I mentioned, that if you don't cool your battery completely, you can have reignition. And you saw how energetic the cells are, right? It can come above and then come all the way here. So you have to be really careful about that also. Make sure that you're not very close to the burning battery, but still are able to put it out with complete cooling.
Thank you. I think